Hello LinkedIn community. I'm Fahim Khan, a data scientist and MLOps engineer with passion for building practical ML solutions. Today I'm excited to present my end-to-end MLOps food delivery time prediction project. This 15 minutes journey takes us from grabbing data from the Kaggle to deploying a live app using Python, Docker, Redis, Comet ML, and more, and tested it on AWS. But since I ran out of free credits, I deployed this on Render to show its works. So recruiters, here this is my showcase of real world skills. Let's deep dive into the every steps. So this is my GitHub repo for this project is a front end part. So imagine ordering food online. You are hungry and you want to know when it's arrived. For delivery companies, getting that time for customers a big deal. It's keep customers happy, helps plan drivers and cut costs. My project predicts delivery time in minutes using 12 factors like traffic, weather, road traffic density, is the festival or not, delivery person is, and what is the city means, urban, rural, metropolitan. These the features. Why this valuable? It's not just a number. It's a system that works for live spotting chains like sudden traffic spikes. So it's a reliable and scalable, showing how data science can solve real world problems. Let's see how I did step by step. Here's the flow. I pull the data from the Kaggle. So I pull the data from the Kaggle, then perform some testing on Jupyter Notebook, and also do a model building, which model perform well on my data sets. Then store the data in Redis and training with XGBoost, and Comet ML tracks my experiments online. A Flask HTML, CSS, JS, and predict times, and LV detect checks for data drift. It's all packed in Docker and deployed originally for AWS. Now it's on render. My tools: Python for logic, Docker for consistency, GitHub Action for automation, Redis for speed. I use my project structure, and main folder is src folder, which contains data ingestion, data processing.py, frozen store, logger, custom exception, model training. Yeah. And also that I have the artifacts folder for models, and saving the models, and static for css and javascript, and template for html, and config for paths, config neat and progress. So these are the whole walkthrough form of my projects. Let's deep dive it step by step, nice and easy. First of all, let's go to the data ingestion part. Basically, it fetch the data from the Kaggle and download in test and CSV, uh, into the and load my data into Redis using feature store.py. Is the feature store used to save the data on Redis and also help to get the features from the Redis. It's like a fast box stores 500 rows like reference zero, distance, weather, sunny. So then I've performed testing on notebooks. So here's my Jupyter notebook. So testing, figuring out what's good. Here's also perform. So I check which technique is best for my project according to my data sets. After that, I go for data processing.py file. So it's clean up, it fills missing spots, like if ratings are blank, turns fog into two, makes new columns like distance, traffic. It's tidying a messy room, everything sets. Then for feature store.py, I push my clean data into Redis, 100 rows, and grab it later with the get batch features method. It's quick, like picking a book of a shell. Then I have the model training.py file. Train the models. I split data into 80% training and 20% test. Scale it with standard scale and use XGBoost. I tweak it with the randomized search CV. Uh, and for testing and speed, adapt log to the commit ML pipeline, training pipeline, puts on saving model in the artifacts folders. So here's the model file and as a scalar model pickle file. Then I have the tests folder where I perform some testing, ensure my pre-processing works. So pre-processing works. It's like a double checking my homework, catching mistakes early. So then what is Comet ML? It's my online tracker. So here's my Comet ML UI parts. So basically track all the experiments and settings according to uh, on my models like codes. These are my codes. And so it help to log the experiments. So different matrices out there. So it's plots and shape model pickle in neat shareable, compares runs pick the best which is one. So it's so my compare runs pick the best. It's digital trophy case, so recruiter can see how it's optimized. Now finally have the prediction.fp file. It's app.py file. So it's pull the data from the Redis and scale it and use LEB detect to spot drift like its traffic jumps. I made templates folder for index.html for front end UI part. Also used a static folder for the CSS and JavaScript parts. So you will type a distance or whether it's hit submit and get the prediction plus drift into. And then I have wrote setup.py file. So setup.db file basically it's used for the deploy this project as a package. So finally have the docker file basically. So my docker file packs the app install python, copies from run flask docker compose ml test it locally with redis docker compose up with hits localhost 5000. So after that it's a deployment ml. It's a github. It's means CI/CD pipeline. I use GitHub Action for CI/CD pipelines. So this automatically perform all the steps, including the tests, and finally deploy this product on AWS Benstock. I ran out the AWS free credits, so I switched to render. No change in my GitHub repo setup. So just a demo tweak. It's a live here, so showing its work. So what's the pro level? What's the means pro level? So basically I apply key logs like predict validation age should be not less than 18 or not greater than 70. Also, so it will able to log this in log folders using logger.py file. So it's comment I will track my runs every skills. So, what's the result? Prediction hits in 5.6 minutes. So, say this when we're going to predict delivery time, it will successfully predicts 5 to 6 minutes of solids, fully polished docs included. This is my end-to-end skill sets, Kaggle to deployment, ready for your team. Uh, so, I love to bring this experience to your company. Let's connect.